Hello, this video introduces a new pen testing tool called Sig Hunter and provides a small how-to of how to use version 1 of the tool. So Sig Hunter is a small but fairly effective PowerShell script that attempts to identify signature sections of malicious files that will inevitably, upon use of the files, trigger AV or EDR. The tool was developed to help penetration testers navigate around signature-based detection tools and therefore allowing them to focus more time on testing those more effective defenses like behavior-based detections or alerts. Version 1 of Sig Hunter operates in two main modes. The first one is Windows Defender detection mode. This scans the file using Windows Defender, and it does this repeatedly using a binary tree search method for effectiveness and an attempt to identify sections of the file or parts of the file that are signatured, causing Defender to alert. The other method is a file deletion mode. What this will do is it will drop the file on the disk and it will wait to see if the file is deleted over a period of time that varies based on the arguments provided. This method has the potential to work against multiple EDR solutions, which is why I included it. Part of the appeal of Sig Hunter is the fact that it actually is a small and fairly discernible PowerShell script. So as a result, it's fairly easily modifiable to meet your needs. Theoretically, you could modify just a few parts of the file and find yourself using this to test against other EDR solutions without being reliant upon the file deletion method, which is reliant in itself upon those EDR solutions actually deleting a malicious file when it does drop the disk, which is not something that all the EDR tools do. Another relevant question that should be answered before starting is why PowerShell? So I opted to write Sig Hunter inside of PowerShell because I wanted it to theoretically be able to run inside of a client environment. So let's say your client is running an EDR in their environment that you don't have access to inside your development labs, and it's a cooperative penetration test. Well, theoretically, you could, run this inside of their environment knowing that you're going to trigger quite a few alerts, and then in doing so, identify those parts of a file that are signatured, make modifications back in your lab, bring a new version, and thereby bypass whatever EDR solution they're running in their environment. And as a result, continue forward with your test, again, focusing on those things that are more relevant to actual security than signature-based detection, instead looking at things like, behavioral-based detection. I'm going to now demonstrate an example usage of the Sig Hunter tool by scanning the application Rubius, which is a prominent application used by pen testers and adversaries. It's highly signatured and will definitely flag several alerts from Windows Defender. Shout out to IPSEC as I do this, as this tool was developed specifically based on the antivirus evasion techniques that are demonstrated in one of his YouTube videos. I will post a link to that specific video inside the comments section or the description section of this video. The first thing that's going to happen as I run the tool is it's going to give me a prompt asking, have I turned off real-time detection with this Windows Defender? The reason why it's important that we do that is because Sig Hunter is going to take a copy of the malicious file in memory and temporarily write it into the temp directory of the computer. And if real-time detection sees that and deletes the file, it's going to make it really hard for Sig Hunter to be accurate in determining, especially with this technique, because they won't be able to scan the file that no longer exists. So bottom line, for using the specific test with Windows Defender mode technique, you need to make sure that you turn off real-time detection. As we begin scanning, we see we already begin to get a few returns back. So get ticket is a string that is located inside of the file that is a problem, as is we see impersonate user and KRB key, and we actually have the specific byte of memory with which the signature begins, along with it's continuing to return more strings, impersonate user, another impersonate user. Here we have another flag that appears to reference, KRB key. That's going to be clearly something we're going to have to look for as we go back to the source code for modifications. Likewise, again, we have similarly a reference to KRB key. Another reference to KRB key. Looks like a reference to a base 64 call for an object property of Kirby. Impersonate user. Again, impersonate user. Clearly, that's going to be an issue that needs to be addressed with a find all and replace, as is KRB key. And the last thing we get is this reference to a GUID, which should be fairly easy to fix. So now the next thing to do is to open up the source code and begin making changes. We'll start with that git ticket. So I'll do the obvious thing first, and I'll start looking through the entire source code for literally the string, git ticket. So let's give that a shot. Make sure I'm not searching for regex. Matching all word is fine. Okay, so get ticket does not occur. So let's try some different variations of get ticket. Removing the underscore for some form of space, using regex, of course, that would help. So no, it's not that. Let's attempt to search for an actual get function addressing a variable name of ticket. So that syntax would look something along the lines of this. Here's one. So that's potentially a suspect. Is there any more of those? I'm just trying to modify my syntax here to make sure I'm getting all the potential instances of it. Theoretically, there could be a number of spaces there. Let's try that. Doesn't identify anything else. Okay, so let's go ahead and begin renaming these. I like to rename them inside of the IDE because it automatically renames, reassociates any usage of this variable with new variable names. So it makes things way easier than they used to be. I'm just naming these ticked instead of ticket. Simple, doesn't really affect anything as far as I'm aware. Let's try KRB key next. There is one instance of the string value KRB key. Let's go ahead and replace KRB key with, I don't know, KRB key, double E. Probably should match case and match whole word. And because this is just a test, I'm going to go ahead and say replace all. So there's 15 occurrences of the words KRB key inside the application. So we've changed all of those to KRB key. And the next string we're going to worry about here is impersonate user. For the sake of a quick test, I'm just going to replace these with a typoed version of the same thing and replace 7 instances. We'll see if that works. That takes care of the impersonate users. That takes the next. Let's do this base60 forward version here with a value of Kirby for a variable name. Let's see if we can find Kirby. Should be near a base64 based operation. So there are quite a few references to Kirby. What about as a... There we go. That is definitely going to be the problem. And it's inside of a console.write line, so I'm really not worried about that being accurate. I don't think that's going to affect any logic, so I'll change that to Kirby. And the last thing I see here that we haven't addressed is the GUID. So now, how do I change the GUID for a project? Let's see. Copy and paste. Not found. Turning off regex will definitely help. So I need to change the assembly GUID. Interesting, I changed the letter to a G, it doesn't work. Oh, it's got to be a hex value. So E would work. So I've officially changed the GUID. And I'll rebuild the solution. So we'll try scanning it again. See if it, again, it's asking me, is Defender on? Do you want to continue? And there does still appear to be a signature with get ticket. So I see the section of memory with which is affected. And so what it says there is that if I change that specific byte of memory, 00051E65, it will cause it so that no longer will that section of memory create an alert, right? So if I change it to a different value, it won't create an alert. So let's go look at that specific section of value. The other statement that the tool outputs, which is the starting byte, is an attempt to guess where the signature starts based on common breaks inside of memory, such as 0 zeros, 2 zeros, etc. So let me find that. I'm looking inside of Notepad, which is not the most glorious method of looking at assembly code, but it is also very quick and dirty, and again is doable inside of your client environment commonly. So that's why I'm demonstrating it here. Let's see. So there is definitely a tickets.getTickets. Oh, plural, get tickets is the signatured area. Okay. That's right. We decided it was a tickets call to get. So let's use our regex to find any potential method of a call, a get call to a parameter value or a variable name of tickets. And there is one, but I don't think that's it. Yeah, that looks more like it because it's actually just the variable name tickets and it is inside of. Again, rename this tickets, double Z. Maybe that's excessive. Any more? Just a comment, get rid of that. Likewise, change this to tickets with a Z. Get rid of the comment, that shouldn't theoretically affect anything. And there are no more instances of a call to get tickets. So great, let's build. Build, no errors. And returning over to do our scan again. Rerun the exact same snippet of code. And based on the fact that it returns so quickly, we now know that this file is no longer signatured. So let's now go and run it to make sure it works. And there it did run. Now the all-important last step, might as well go turn real-time protection back on and determine, without the aid of going to the PowerShell script, let's just go scan the actual file. Scan it with Defender, and it returns the same result, which is no files were detected. I'm copying this from a folder where it is immune to being scanned, as is in my dev folder. So let's try it out here on the desktop just to make sure. Scan with Defender, and lo and behold, one file scanned, 0 threats found. So again, we've officially modified the file sufficiently to where there's no
That concludes a pretty simplistic
demonstration of Sig Hunter. Again, it will work on pretty much any file you throw at it. I've used it quite a few times in multiple tests recently against several different payloads and file types. As a matter of fact, I found one where just changing one bit inside of a default Cobalt Strike payload, I was able to get it on disk and functioning, bypassing the EDR solution that was in my client environment. So this is a fairly effective means with which to run those signature-based detections. Again, help you focus on those behavioral-based detections, which are, I think, more important in protecting the client environment. But this is a necessary evil that we have to circumnavigate, and for sure the EDR people should be, fielding this as part of the defenses too. Again, 200 lines of code. It's not that big. Eager to see how or if the community chooses to use it and tweak it as needed.